Welcome to this session, guys. In the previous session, we have understood the transport layer, right? What are the key features of transport layer? What is transport layer? Where it is located in the model, TCP IP model? What are the key responsibilities of transport layer? All these things we have seen, and we have understood that checksum, that is maintaining the integrity of the data transferred, is one of the key responsibility of transport layer. So how that integrity will be maintained? It is maintained with the help of checksum. So in the today's session, we will try to understand the checksum in more detail. So what is checksum? So before that, let us start with a person here. He is one person. He is sending a message to the other person, for example, or server. Okay. So these are the data packets which are going. Okay. Now what happens? How to make sure? Have you ever wondered that whatever is sent from this guy, how it is getting received exactly like that? Because there will be lot of people, lot of hackers in the middle, right? There are a lot of hackers who are ready for hacking the data, ready to intercept the data. How that is possible, right? So, for example, consider you have drafted a letter to your mom. Okay, to your mom you have drafted a letter. You are telling that send 5,000 rupees, 5,000 rupees, okay, to Mahesh. Okay, you send this letter. Okay, now it is going to your mom. This is your mom, for example. Okay, but it is tampered in the middle. What letter she is receiving is send 500 to Umesh, for example, right? So altogether data got altered, right? So who would have done this? This is a somebody in the middle man who has tampered this data. So how to prevent this? So how it will be prevented usually? So there should be some signature, right? Or some package which you will put on the top of this, for example. Okay. And if it is intact, right, throughout the journey, if it is intact, means your packet is not tampered. It is proper. This is the way you can make sure that whatever is sent will be received as is. So in the digital world, how this will be maintained, how this will be managed? This is managed with the help of checksum. So checksum is a digital signature of the packet. Okay, it is a digital signature of the packet. So basically, a checksum is a small value computed from the data to detect error during transmission. So what happens is whatever data you are sending, right? Suppose, let me erase this one. Now, let us say you are sending a data as 101011000110. This is the data which you are sending. Now, what is this checksum is? The checksum will add all these binary numbers, for example, and checksum will be computed. Like it will be this one 0110. Okay, for example. Okay. Now this checksum will be attached to this packet. This is this packet, okay? This is this packet. So it will be attached to this packet and it will be sent here. Now what happens as soon as it is received at this guy, right? So he will also carry out the sum of this number. Okay. And if the sum arrives as 10110, then he will understand that whatever is sent is intact. It is not tampered in the middle. If slightly the sum is getting changed, right, then he clearly understand that data got tampered, the packet got damaged in the middle. So if sender checksum equal to receiver checksum, then data is correct, accept it. If sender checksum is not equal to receiver checksum, data something has changed, data is corrupted. And in case the data got corrupted, then TCP, if you are using TCP, then there will be a request for retransmission, retransmit the data. So this checksum ensures a reliable communication. Correct? So whatever is sent will be received. So let us take a real life example to understand it better. Okay. So for example, now you are sending a data. There will be a data chunk. Okay. CHUNK. Chunk 1, chunk 2, chunk 3. It is like 5, 7, 9. These are the values of this chunk. Okay. And you are sending this chunk inside a data packet. Okay, so sender calculate the sum of this 5 plus 7 plus 9 equal to how much? 21, right? So this packet will be sent like 5, 7, 9. For example, this is the packet. Now it is going to the receiver. Now receiver receives this packet in the similar way, right? 5, 7, 9. He will also compute the sum and he will come to know that the sum is 21. Whatever is sent is matching with the sum, right? So he will accept it. And in case it's not matching, then he will discard that package and ask for retransmission. So this is what about the checksum. In real life, this is I have given a very real life example to make you understand checksum, but there will be lot of complication is making the sum and all. But that is not important for us to understand in detail, right? But the concept we should understand. So some of the fact about this checksum is even a single bit flip. If we are sending 000110, right? Even a single bit flip is detected by checksum. It is that much powerful. And we have seen TCP uses checksum to guarantee end-to-end reliability. So reliability is one of the feature of TCP which is achieved with the help of checksum. UDP also uses checksum, but upon correction, it doesn't retransmit the data. It just detects that the data is corrupted, but it doesn't retransmit the data. So these are some of the important facts about the checksum. In one line, if I want to explain you at the end of the session, is checksum is like writing a total on the bill. If the items change, the total won't match, and you instantly know something went wrong, right? So that is what is checksum. Okay. In the upcoming session, we will try to understand now where this checksum actually fit in the TCP header. All these things we will understand as we move forward in this series. So if you like this video, do like, do subscribe, do share it with your friend. It will help me a lot. So thank you.